Hi friends, in this lecture what I'll try to do basically is get everybody acquainted with the concept of rigid body. Now what is a rigid body basically? For example, if we have some kind of a body like this, example, alright, this is one kind of a body, and suppose we take 2 points. The points are A and B suppose. Now apply a large force, infinitesimally large force. Now this body is said to be a rigid body if there are no internal deformations such that the relative displacement between A and B points are effectively zero. Therein we can say that this body is a rigid body. So essentially this body is a rigid body if delta AB is equal to 0, whatever be the forces that are applied. Now in strength of material we will essentially see that the whole difference between rigid body mechanics and strength of material is that in strength of materials there will be certain relative displacement between A and B, and we account for this displacement in the form of strain. So this is the basic difference between rigid body mechanics and strength of materials. The next thing that we are going to do is understand the concept of degree of freedom. Now what do you mean by degree of freedom? Basically degree of freedom are certain independent variables that are used to define the complete displaced geometry of a body. Right. Now what does that mean? Basically, if you take for an example of a 3D plane suppose, right. For example, this is my y-axis, this is my x-axis, and suppose this is my z-axis. Right. Now I have a body, and suppose this is my body. Right. And this body, it can move in this 3D plane by having certain independent variables of translations or rotations. Number one, this body can move in the x direction, and this movement in the x direction is not dependent on the y or z direction. So it will have one independent translation in the x direction, because whatever be the movement in y or z direction, it won't have any bearing on the movement in x direction. So let this translation be u. U is the translation along x direction. Similarly, this body will have a translation along y direction, so let us this be v, and it will have a translation along the third axis, that is the z direction, and let us name this as w. Now this body can also rotate in the sense that this body will have 3 axes basically, right? So to define like that, this body will have, suppose this is my y-axis, this is my x-axis, and this is my z-axis. Now this body can have 3 types of rotations basically. Number one, it can rotate about the x-axis. That is, if this is the x-axis, the body will rotate like this. Right. So there is one independent rotation about x-axis. The body, if this is my y-axis, the body can rotate like this. So there is one independent rotation about y-axis also. And if this is my z-axis, the body can rotate like this. So there is one independent rotation about z-axis also. So essentially this rigid body in this 3D plane has got 3 independent translations. I say independent as I, and translations, and 3 independent rotations. Right. And 3 plus 3 is equal to 6. So 6 independent movement variables that are required to describe the complete displaced geometry of this body in this 3D plane. And these 6 are essentially called the degrees of freedom. So this is degree of freedom basically. Degree of freedom basically means that in a 3D plane, how many displacement variables it can have. It can move about x-axis, it can move about y-axis, it can move about z-axis, it can rotate about either of the 3 axes. So these are its 6 independent degrees of freedom. And we say that a body in a 3D plane has got 6 degrees of freedom. The next concept that we are going to deal is, if we restrain this to a 2D plane, then what will happen basically? If we cut out this plane suppose, we cut out z plane and keep it restrained with x and y plane, then essentially this body will have how many translations? Let's see. For example, this body then can move about x-axis, can move about y-axis. So there will be 2 independent translations, 2 independent translations. Here what we are doing is essentially constraining movement about the z direction. That is, it cannot move about z direction, right? So it is fixed. It is fixed in a 2D plane and it will move in the 2D plane, not in a 3D plane. So two independent translations are there. It can move over x-axis, it can move over y-axis. Now, there are two axes of rotation here, x and y. Can it move about x-axis? No, because we are not allowing any kind of motion about the z-axis. So if it has to move about the x-axis, it will have to rotate in the yz plane. That is, it will have to rotate in this plane. And we are not allowing, as this is a 2D plane, we are not allowing that. So x-axis, it will have no rotation. Y-axis, it will have to rotate in the xz plane. So we are not allowing this too. But if you take the z-axis, it will have some kind of a rotation about the z-axis in the fact that it will move about the xy plane, which we are definitely allowing. It will move about the xy plane. So one independent rotation. So just by constraining movement about one axis, what we did basically is to convert the 6 independent movement variables or the 6 degrees of freedom to 3 degrees of freedom. And essentially we'll deal about 2D elements right now, right? So essentially a rigid body will have 3 degrees of freedom, and this, a planar rigid body, has 3 degrees of freedom, right? A planar rigid body, because it moves in a 2D plane, and it will have 3 degrees of freedom, movement about x-axis, movement about y-axis, and rotation about z-axis. And that's all for this lecture. Thanks a lot for listening. Thank you.